Hello, ladies and gentlemen. Root Beer here, and I hope you're ready to take a look at question number 15 on our 2011 Alberta High School Math Contest. The lengths of the sides of triarticle, that should obviously be an N, although looking at my keyboard, N and RT are nowhere near each other, but okay. So that's a more interesting typo than the space E that they had a couple questions ago. That's interesting. I don't know how that got past anyone. Oh well. The lengths of the sides of triangle ABC are consecutive positive integers. D is the midpoint of BC and AD, and it's sorry. D is the midpoint of BC, and AD is perpendicular to the angle bisector of C. The product of the lengths of the three sides is. If we look at our answers here, 24 is 27 minus 2. So this is 2 times 3 times 4. 60 here is 3 times 4 times 5. And this is 4 times 5 times 6. So all of these are just multiples of consecutive numbers, so that's not helping. But, I mean, at least we don't have a sort of a none of these options. Oh, look, they did it again. A little space here. But at least we're not having a none of these options. So we definitely know this can be done, and this should be enough information to determine this triangle. So we got ABC. Sort of a generic little ABC here. Now D is the midpoint. And then AD happens to be perpendicular to the bisector of C. I'm going to redraw my triangle a little bit. I'm going to start by making my angle C, because that's the thing I need to split. And so its bisector look a little something like that. So if I place A here, then this is perpendicular to the bisector, so this will be D, and we just double this to get B. All right, so that's a more realistic looking triangle. All right, so we've got perpendicular here, we've got a bisector. So inside ACD, the bisector of C is also an altitude. We could even call this little intersection point here E. CE is a so E is, we've got the perpendicular bisector here. That's kind of interesting, and that should really only happen with, yeah, so we split this angle here in half, then you've got right angles, you got this common angle here, so 90 minus the dot, which I'll call check, has to be in both of these spots. These are similar triangles, but because they share the same side, CE I'm calling it, they must be congruent, so this is an isosceles triangle. That's the only way an angle bisector also gives you an altitude, is if you're looking at an isosceles triangle. So this big triangle here is isosceles. These two smaller triangles are therefore congruent. So what can we do here? Well, I know the sides here are, start to look like n minus 1, n plus 1. I don't know which side is which, although, whatever this side is, BC is bigger than it, right? So if you call this x, this is x, so this has got to at least be x plus 1, possibly x plus 2 if this one's supposed to be the n minus 1 here. So there's that relationship. So, okay, I know BC is bigger than AC, but D is the midpoint, right? AD is perpendicular to BC, but D is the midpoint. We just use that to construct it. So this is x, so BC is twice AC. So we need 3 consecutive numbers, one of which is twice one of the others. So that leaves me with only a few possibilities. Maybe n plus 1 is twice n. Maybe n plus 1 is twice n minus 1. Or maybe n is twice n minus 1. Those are the only 3 possibilities. Now, I'm guessing only one of these should work out, and give us proper triangle. Like this first one here, subtract n from both sides, and you'll get 1 has to be n. So you're looking at a triangle that does 0, 1, 2. Right? So that's not a triangle because you can't have a side length of 0. Okay? But if my lengths were n minus 1, n, and n plus 1, these are 3 consecutive numbers. And so this clearly isn't the relationship we're looking for. So it's not that this side is n and this is n plus 1. And that wouldn't work. Okay, what if, so expand this, we get 2n minus 2. Add the 2 to both sides. You'll get a 3 over here. Subtract n from 2n, you'll get n. So n is 3, so you'll get 2, 3, 4. That would give us the product of 24, which I think was answer A. And that seems to be okay. This side then gets doubled to be the 4. How about down here? If I had 2n minus 2, bring the 2 over to the other side, subtract an n, you'll get n is 2, and so you'll get n minus 1, n plus 1. Those are 3 lengths as well. Now 6 isn't an option here. There's got to be some reason it's not. Oh, because this isn't an actual triangle. Because you need to have these 2 smaller sides add up more than the largest side. And that doesn't happen here. So you get what's called a degenerate triangle. Basically, everything lies flat together. You don't have any real area here. So 2 times 3 times 4, 24. And I did just spy that that was A. All right. So we had to... I mean, the midpoint stuff was quite nice. Gave us a quick little relationship. But it was really this perpendicular also being the bisector, giving you an isosceles triangle, giving you 2 congruent triangles. That, I think, was the biggest help there. We see A is our answer. All right, fantastic. So that was question number 15. We have just one more question to go, and that'll be question 16. We'll take a look at that in the following video. Take care.